the parts of the screw jack. First we'll start with the body. It is very easy, and we'll go to sketch and we'll choose the front plane, and the details of all the parts of the screw jack are given in this PDF. You can download it from the link given in the description box also. And this is the body of the screw jack, and here we'll use the option revolve since it is cylindrical like profile. And first we will draw the rough sketches, and now first I am going to make a reference axis about which I am going to use or revolve. So I am going to create a line, vertical line for construction, and for it is an infinite line. So I am going to place it on the origin, and then I am going to click on OK. And now I will be making the part. First I will not add the dimensions, later you cannot, or simultaneously also you can go on add it, but it will take a lot of time. Only the hashed portion we are doing, because only material is there, and since it is half hatched, there is section is cut at the center and only half section is there, right half it is section. So only this much if we draw and revolve it will be there. Except this, everything will be hollow over here, and this profile will be same on the left side, and the other thing except the hatching thing, everything is hollow. So hollow thing we are not going to draw, and the profile is we have drawn, and I'm going to add the constraint as coincident so that this and this line should coincide. And now I'll go to smart dimension to add the dimension, and this one they are given as 20 mm. It is 20, and from this end to this end, the outer diameter here they are given, it has 140. So we are going to make only the half, so it will be 70. 140 divided by 2. You can see that sometimes it moves. You can just use the mouse and drag it, because we have not constrained it, so it has the ability to move. And from this point to this point we'll add the dimension now. It is 100 mm in diameter, again it is half, so it will be 50, and this height is 3 mm. You can see here it is 3, and from this end point to this end the diameter is 100 again, so it will be a same as 50. So you can add the dimensions by specifying the dimensions also, or you can also add like this, or since you have already mentioned the 50 mm diameter over here, and you just make sure that these two are coincident, and you can see this line has turned black. And now from this to this we'll add the diameter. The diameter is 70, outer diameter, and the inner is 50. So again it will be half, so it will be 35, and this one is 50, so it will be half, 25. I'm going to add this one height. Height is 40 mm, and this, since we have not added this constraint, it has the ability to move, so we can again adjust it, or you can leave it as it is and then you can specify the dimension. This one they are given the diameter as 66, so it will be 33, and this one is going to be of 1 mm. Okay, it is already constrained. Now again it shows it is not fully defined, so first I'll add the parallel constraint to this, and now I will specify the distance between these two it is 10 mm. And again it shows that it is not constrained, so we'll just add this dimension and see. Now it shows it is fully defined. And we need to add the overall height, and the overall height is given as 185 mm. Yeah, now it is fully defined. You can just drag the sketch, drag the dimension outside the sketches so that you can easily identify the dimensions. And we'll exit the sketch, go to feature, and now we'll use the option revolve. By default only one profile is there and only one axis straight line is there. It is selected. If it's not chosen, you just go in the axis of revolution, select the axis about which you need to revolve, and if the profile is not selected, go to here and select the profile, and then we click on OK. Remember, using these features tab, they should always be a closed profile. If the profile is not closed, you cannot use any of the options. And now here they have given the radius, that is the fillet of radius 8, and here they are specified is not properly visible unless otherwise stated, dimensions in mm, and chamfer is 1 into 45 degrees and radius is 1 mm. So here there is a fillet and here also there is a fillet. They have not stated it, so it will be 1 mm radius fillet, and here they have specified it as R8, so it will be the radius of 8 mm. So we'll go here and add the fillet. You can add the fillet in the sketches also. It makes the sketch little bit complicated. If you want, you can add over there. First I'm going to select this point and I'm going to choose this one also, and the radius I am going to specify it as 1, and then we'll click on OK. Now you can see the fillet here and here also, and now I will go to again the fillet and I'll apply here, and now the radius is 8, and we'll click on OK. And now the body we have done. The tree, you can see the material is not specified. Go right click and here you are having the option called manage favorites, and here it shows the list of favorite material. You can just add the materials to your favorites and just select from here itself. And a given material is made of cast iron. The body is made of cast iron. So let us see if it is there in the, no, it is not there in the favorites, so we'll go to edit material. And in the search type cast, yeah, you can see there are two types, gray cast iron and malleable cast iron. You can choose anyone, they are not specified properly, and anyway we are not going to use it, all this property for the analysis. So, and almost will be the same. Here we will use gray cast iron, and then we will click on apply, and now here it shows the gray cast iron. The material has been applied and the color changes because by default in the SolidWorks material library for standard materials there is a standard physical appearance given to it and the physical properties also. Example like yield strength and Young's modulus, all those values will be given by default in the SolidWorks default library. And you can change it, and if you want now the appearance to be changed, go to display manager over here, and here you see the cast iron material is applied. Here you can just add the appearance. This contains a list of different default materials. You can add from those, or you can just choose the, just for the physical appearance if you are making, just to distinguish between different parts, you can just add the color from here itself. And now we'll go to file and properties, and here in the custom you have to give the material. This one we are going to create because finally in the drafting or in the assembly, we are going to apply the bill of materials, that is BOM. There in the material, this material should be displayed. So here we'll add that and we click on apply, and now we'll see how to use the suction view. Go to suction view over here, and by default the plane is selected, any one of the front plane is selected. If the plane is not selected, here you can choose the top, right, and the front plane here itself, or if you have any other planes created, that plane will be visible over here. You can just choose and you can just move it and rotate it any direction you want. By default now I want only the front plane, because I want to make sure whatever they have specified in the drawing, that is the suction, that material is there, I want to just confirm. So yeah, everything is there, and you can change the view over here to I'll make sure that yeah, and everywhere it is the same, and we have created the proper body. Now I'll change back the view back to shaded with edges. And thank you for watching my video. Please like and subscribe my channel for more videos like this, and comment below for any suggestions.